right, we're going to do some multi-step graphing. For these problems, we're just going to graph, just like we did when we did yesterday, multi-step graphing. We're going to do each individual graph. Some of you might be able to do all of these transformations at one time. If you can do that, that's fine. Skip to the last graph. But some of us might need to break it down to make sure that we're accurate. Either way is fine, just make sure that you're accurate. All right, so the first thing we have to do is identify the transformations. So let's see, I have a minus out in front here, which means I'm going to reflect over the x-axis. And that's the first transformation I'm going to do. The next thing I see is a 1/3 inside the parentheses. The 1/3, if I look at the transformations chart here, it's the bottom little green box. 1/3 is less than 1, which means we have a horizontal stretch by the reciprocal of 1/3. Oops, this is what I want. So I have a horizontal stretch by the reciprocal of 1/3, which is 3. And then the last thing we'll have is a +4 on the end, which means your graph is going to go up 4. So let's get started. Reflecting over the x-axis is a rigid transformation. It does not change the pattern of the parent function. So you can go ahead and plot those. Now, if you feel like I'm going really fast on graphing these, pause the video so you can catch up. Now, a horizontal stretch is changing the x values. I'm going to change the color of the x values here so we can reference them. So horizontal stretch does not change the origin. That's going to stay at 0, 0. When I look at the next point here, I'll go to the right. I have the point 1, -1. The y value is going to stay the same. It's still going to be -1. The x value is going to be multiplied by 3. So 1 times 3 is 3. So I have the point 3, -1. The next point I have is 2, -4. The y value stays the same. The x value needs to be multiplied by 3, which would give me 6, -4. And then I do my last point, 3, -9. Again, the y stays the same. The x value gets multiplied by 3. So we're all the way over here. Then you can connect those points. And lastly, what you're going to do is move that whole graph up 4. So I'll go to 0, 4, 3, I think that goes up to 3, 3. Let's see, 6, -4 will go up to 6, 0. And 9, -5. I think I did my algebra right there. And this should be your final graph. And again, if you could do that all in one step, one graph, that's fine. Make sure you list the transformations and put your graph at the end. All right, let's try the second one. In B, what do we have? We have -2 in the parentheses, x² -2. So the first thing I notice is a negative in front of everything. Well, I'm sorry, it's not in front of everything, it's inside the parentheses. So that means we're going to reflect over the y-axis. Now, I have a 2 next inside the parentheses. And that 2 is a number greater than 1, which means, it's right here, which means that it's a horizontal compression by the reciprocal of that value. So we're going to have a horizontal compression by 1/2, a reciprocal of 2. And finally, the -2 on the end means you go down 2. Now, when I reflect over the y-axis, and I take this parent function right here, if I flip it around, it's going to look exactly the same. So if you want to, I wouldn't regraph it. I mean, you can if you want, but it's going to be that same parent function. So we can skip that box. The y, reflecting over the y, is not going to do a lot for us in this unit. Horizontal compression by 1/2. Change those x values. The origin stays the same. My next ordered pair, 1, 1. The y is going to stay the same, but the x is going to be changed by 1/2. We're going to multiply it. So the point I'm going to plot is 1/2, 1. So squeeze it in there. It's a little tiny. Then I have 2, 4. Again, the y stays the same. The x gets multiplied by a half, which will be 1, 4. And finally, the 0.39, the y stays the same, and the x gets multiplied by a half again, which is 1.5. So 1.59 right here. So it's a skinny little graph. And just like the first problem, you need to slow the video down to see the, or to graph it yourself. Go ahead and do that. And we'll start putting those in for us a little bit. All right, lastly, move all those points down 2. So the origin will go down to -2, or 0, -2. We'll have 1/2, -1. Then 1, 4 will go down to 1, 2. And 1.57. There you go. And that's the whole graph. Hopefully you're catching on to this horizontal change pretty easily. Last one, I have 1/2 in front. Oh, this is a challenge here. 1/2 in front, then a negative and a 2 in the parentheses, x squared. So the 1/2 in front of everything, that is a vertical compression. Now remember, vertical compressions, let's look here on my table, vertical compression right here, you're compressing by the number in front, by C. So it's back to what you're comfortable with. The 1/2 stays 1/2 when it's vertical. Inside the parentheses, I have a minus. That means I'm going to reflect over the y-axis. And inside the parentheses, I have a 2, which means that I have a horizontal compression by the reciprocal of 2, which is 1/2. So not only do I have a vertical compression, but I will also have a horizontal compression. So this time I'm making you do both. So let's take our time here. We'll slow it down. Vertical compression. I'm going to write the ordered pairs out. Vertical compression, I started 0, 0. That's not going to change. Now the 0.11, this time on the vertical compression, this changes the y values. So the x here stays the same. The y value gets compressed by a half. Okay, 1 times a half is half. So I'll have the 0.1, 1/2. Which is, oh, right here. Okay. Still in horizontal mode and my brain has switched over. The next point, 2, 4. The x stays the same. The y gets multiplied by a half. So 4 1/2 is 2, 2. And then I have the 0.39. Again, the x stays the same. The y gets multiplied by 1/2. So 3, 4.5. And we have room here. I'm going to do the next point just so that our graph is really accurate. 416 we can also fit on here. The x stays the same. The y gets multiplied by half. So 4, 8. All right, so here's our graph. So it does look a little wider, but it's wider for a different reason. It's wider because we shrunk it down from in the height direction. Reflecting over the y-axis is not going to change that graph. So I'm actually going to skip that box. The graph's going to stay the same if I flip it over the y-axis. Now let's do a horizontal compression by a half. I'm going to start, I'm going to not rewrite all of them. I'm going to start with these points right here because those are the points on my graph. 0, 0 is going to stay the same. Now this point, I'm changing the x value by 1/2. So the y value is going to stay the same. The x value gets multiplied by a half. So now I'm going to have the point 1/2, 1/2. Okay, so it's going to be right in the middle of that first box, which is really hard to see on my smartboard, but hopefully on your paper you've plotted okay. Next, again, this time the y value stays the same. I'm multiplying the x by a half, which will be 1. So you're going to plot the point 1, 2 right here. All right, 3, 9 is going to change. The y stays the same. The x gets multiplied by a half. So 1.5. Oh, I'm sorry. I read it wrong. 1.5, 4.5. Uh-oh. I'm making a mess. Here we go. Okay, so 4.5 stays the same. The 3 gets multiplied by half. So I have 1.5, 4.5 there. And lastly, 4, 8. The 8 stays the same. The 4 gets multiplied by a half, which is 2. So 2, 8, right there. And that is your final graph. It's been horizontally and vertically compressed by half. All right, you've made it through all the notes videos. Try to practice. There are practice videos for every single problem. Try some on your own, check the key, and if you need the video, then go back for the explanation.